Hello and welcome back to AGT STEM. Today we're going to be watching a video about astatine. So, without further ado, let's hop to it.
85 is astatine. Astatine filled in the space at the bottom of the halogens. Now, of course, it's not at the bottom of the halogens now because very recently tennessine went below it. I'm not sure that I drink it all the time. But at the time it was discovered, it was the heaviest halogen. That is in the group that begins with fluorine and goes down chlorine, bromine, iodine, astatine. Astatine was known to be, or expected to be, really radioactive. Now they knew there was an element should be there for two reasons. First of all, because if you looked at the periodic table, they appeared to be a hole, but that's not terribly scientific. But using the experiments that had been done in the early 20th century by a physicist called Henry Moseley, they knew that by the X-ray emissions of the different elements, there ought to be an element between polonium and radon. So
That's kind of cool how they can see the test of this element and this element and then know that there's one missing. Like, I just think that's kind of cool.
Searches for astatine in nature failed. There was no obvious traces of this missing radioactive element. So in the end, it was decided that it should be synthesized by taking bismuth, which is element 83, and bombarding it with alpha particles. Alpha particles are nuclei of helium, was element number 2. 83 plus 2 makes 85. So you imagine the accelerated alpha particles hitting the nuclei of the bismuth, and eventually one of them will fuse and you will get an atom of astatine. Now this is similar to the more modern approach which has been used for the super heavy elements, but astatine is much more stable than those. So once you made an atom, it didn't decay immediately. So you could build up modest quantities of astatine, but not nearly enough to actually see any of the solid material. After astatine had been discovered or synthesized, it was then discovered in traces amounts in minerals. Once you know the emission signature of the radioactive particles coming out from its decay, you can detect that emission elsewhere. And it's been calculated that if you took all the astatine that exists in the whole world at any one time, it would weigh less than these 3 coins. So that's less than...
That's a very small amount. Those aren't even that, those coins aren't even that big. There's only 3 of them. Very small. Just a little bit.
30 grams, less than an ounce in the whole world. And none of it is in lumps. There's the odd atom here or there which decays quite rapidly. For me, one of the most interesting questions is whether astatine behaves like other halogens. If you go down the group, you would expect, because fluorine and chlorine are gases, bromine is a liquid, iodine is a solid, you would expect that astatine would be a solid, though like francium, its radioactivity might blow the solid apart. But the other point about astatine is that as you go down these elements, they gradually become more and more like a metal. So iodine is strongly colored and sometimes forms positive ions as well as negative ions. Astatine could have some metallic characters, and in chemistry it sometimes seems to resemble polonium, the element next to it, element number 84, more than it does resemble iodine, the element above. Perhaps the most interesting fact, which I think is quite fun, is that for all the other halogens, if you form the compound with hydrogen, hydrogen chloride, hydrogen iodide, the halogen is negative with respect to the hydrogen and you get an acid. And it has been argued that with astatine, it may be the other way round. It may be astatine hydride rather than hydrogen astatide. The reason that it was called astatine is because it comes from the Greek word astato, which means unstable. I think the
Well, that's a pretty forward name, don't you think? Unstable. Makes sense.
pronunciation is right. I asked one of my Greek colleagues at coffee today, and in fact, in Greek, it is still called astato. It means unstable in the sense that the weather is changeable or something like that. So it's quite good because I think if you think about it chemically, first of all, it means it's unstable, it decays, but it also means perhaps it's unstable, it's not quite sure whether it's a metal or a halogen. Well, before I started making these videos, I thought all these elements were very boring and never really thought about them. What I now discover is that each of these elements, when you start delving into it, is actually quite an interesting story. And particularly, they're interesting stories of human ambition and greed among the people who want to claim to have discovered it. And there are a whole series of people. One unsuccessful claimant wanted to call it Alabamine, after Alabama, presumably his home state. So it's quite fun that the element that is now underneath it, element 117, is called tennessine. So
That's kind of funny. He tried to get it named after a state, and then somehow another state got it before him and is right below. That's hilarious. Like, actually funny.
in the end, an American state got recognition, though sadly for that chemist, it wasn't Alabama.
That is very funny. Thank you so much for watching. Oh, I forgot what I was supposed to say. Thank you so much for watching. We'll see you next time. Stay smart. Bye.